got mine done. So if you're done, you can pass it over and I'll see if I got it right. I'll put it up here for now. I didn't know if you were. Yeah, don't get fancy with your sentence. Just write something short for me. The less you write, the less I have to read. No, you're erasing. It was beautiful the way you have it. So very nice. Very good. All right, a few more here. Oh, you're still meditating over there. You're going to erase again? Don't erase again. Let me see what you have. You're writing your sentence. You're going to say put his hand. Okay, now you got it. You're happy with it? Okay. Excellent. You're finishing up. Period. Good job. Now you're good enough, right? Okay, let's do this. I think I've got them all, don't I? Oh, I've got to staple them together because otherwise they get separated in my backpack. Okay. Where's my answers? There they are. Okay, so a couple of pointers as we do this. So one thing is because there's these two averages, you need to know which is which. I usually will tell you. So sample one is the males. So sample one is this one. Sample two is this one. So you could have written it as mu1, mu2, or mu sub m, mu sub f, but you need to know which is which over here so that you can interpret this correctly. Because this one assumes that mu sub 1 is first, mu sub 2 is second in your hypothesis. And so it matters when you get down to left, right, and 2 business here for which p-value to use. But anyway, hopefully you all have this. One of the averages is bigger than the other. And then you've got your hypotheses. It's a right-tailed test. I pulled this right here. That test statistic is so small that once I see that, I know that there's no difference. Like basically that means the averages are basically right next to each other. I know, well, yeah, actually they are. They're within a second of one another. But anyway, getting on, the p-value I've got, failed to reject the null hypothesis, and there is not enough evidence to suggest the alternative. Where's the alternative hypothesis? It's there, but it's also, in this case, the very first sentence. So if you didn't know exactly what to write, here it is. There. That would be a better way to write what I have here, but I was too lazy, so I just said there's not enough evidence to suggest that males are later than females on average. But really, I should say, if I was going to type this up, for a presentation or a paper, I would say that there's not enough evidence to suggest that, and then I would actually write that entire statement there. But I'm into conciseness when you're writing sentences, because the less you write, the less I read, and that makes me happy. Okay, let's move on. So today, it's not an Excel day, but we will use Excel just a little bit. I'll show you how to use the Excel, but mostly we're going to be doing this work understanding what it means to be a dependent sample, because you've already got all of the Excel that you need to do this homework. You just need to know when it's appropriate to use this. So to understand dependent samples, oh, sorry, I just remembered something. I need to say this before I forget. So we have project 2, and I know that a couple of you have been bugging me about getting project 1 graded. I don't know why I haven't done it yet, to be honest. It just keeps slipping my mind. And I've got 5 classes this semester, so that's my excuse, is that it's just, got other things I'm doing. But I will get it done. I always prioritize, by the way, getting your test back to you. So I know you want to see project 1, but I'm sure you did a great job. So project 2. I don't have that up. Well, I do have it. I think it's hidden from you. But the only thing I haven't done is to give you your specific assignment. It's almost exactly the same as the first project, only you're doing a hypothesis test instead of a confidence interval. So I just need to give you the assignment, like sort the names and tell you which one to do. But I'll have that up. It'll be due after Thanksgiving. But just so you know, it's coming. And Monday, hopefully, I'll have it all squared away. So project 2, I suppose since I've got project 2 written here, I should write down get project 1 graded. So that'll be for me to remember, do it now. Do it now. Okay. All right. Well, anyway, hopefully that writing it, sometimes when you write something, it helps stick it in your mind more. Okay. So what we're interested in today is understanding the difference between dependent and independent sampling. So dependent sampling is when you use the same source for 2 sets of data or 2 samples. So it's the same set or related sets of sources are used. So what does this mean? Well, I've got some examples in just a bit, but here's a sort of picture of what you're dealing with is you have a sample and you get 2 variables from that same sample. That's dependent sampling. Independent sampling, on the other hand, is what we've been studying up until now. We just haven't named it. But in dependent sampling, you have 2 unrelated sets of sources. So you have 2 unrelated things. And I know that there's probably some sort of a relationship in the sense that I have students from here and students from another college, and I'm comparing them. So the relationship, they're students, but what I mean by a relationship is there's no relationship between the individuals in the 2 samples. You'll see what I mean by this in just a bit, but here's a picture to sort of illustrate this. You have your 2 samples, and you're getting your individual, like you're computing the average from sample 1, average from sample 2, and there's this wall separating the 2 samples. So that's sort of a picture of what we're talking about when we say dependent versus independent sampling. So a few examples. So you've seen plenty of examples of independent sampling. Independent sampling, we're comparing, say, small nursing homes with big nursing homes. We're comparing students in this section of statistics with students in the afternoon section of statistics. Those sorts of things where you have 2 unrelated sets. So what would it mean to be related? So a related would be something like this. If you have a pre-test and a post-test. In fact, this is exactly what I do with you. Well, not exactly, but similar. I give you a first exam and then a second exam and then a third exam. And so I might say, how are you doing throughout the semester? Are your grades going up or are they going down? Those sorts of questions we could ask of a pre-test and a post-test. We do this at MVNU when we give you, probably some of you as freshmen had to take a test, like a general knowledge test, and then we'll give you the same test when you're juniors and say, look, they learned something. Sometimes they don't, and it's always sad. So anyway, husbands and wives. So if we're interested in comparing, I don't know, let's say we compare the heights the heights of men and women. One way to do that is to compare the men and women individually, just have two unrelated samples. But we could take couples, maybe not husbands and wives, you could have special friends. And I think that we would find that the variability between, like if you have guys and girls, you generally sort yourselves into similar heights, usually. There's sometimes something like this or this going on, but my wife and I are about the same height, and that's what you see people walking around. They're usually about the same height. So husbands and wives, you have something connecting the two samples. You have women, men, but there's a connection, and that connection is the marriages or the relationships. Some side-by-side product testing. So this would be like you have you go and you might have Coke versus Pepsi. And so they have the little cups, and they say, okay, try this one. And you're like, oh, I give that a 5. And then try this one. Ooh, that one's really good. I'll give that a 10 or whatever. So that might be, depending on how they do it, if they just say, which one do you prefer, then it's not so much a dependent sampling. But it's the person. There's one person saying, I rate that a 5, I rate that a 10. And then that person walks away, the next person comes in, and they say, oh, I like that one. That one's 7, and this one's a 2. Or whatever it is. So you gathered your data, and it's the people making the assessments that connects the two samples. Okay. One other thing that might be the case is you could have what are called matched pairs sampling, which allows us to use the dependent sampling. You see, the dependent sampling is powerful because it reduces the variability. I don't know if you remember in that video, the Mythbusters, the guy, whoever it was complaining about how much variability there is. And when there's a lot of variability, it makes it hard to come to conclusions about samples. So if you can reduce variability in any way, it's really helpful. Matched pairs, what you do is you have unrelated samples, but you have something that connects them. So you say, okay, we have these two samples. Maybe it's the morning class and the afternoon class. And then what I might do is I could connect you by maybe, and I know not everyone takes the ACT anymore, but back in the old days, everyone took the ACT test to get into college. And so I could connect you by your ACT score. For example, take the 2 top ACT scores, and we'll say, okay, you two, I would do this on a computer, not on, I'd sort you all, and then I'd say, okay, these two are matched up, and then these two, and then these two, and these two, and so forth. That way, when you take your exam, you're just comparing apples to apples, instead of comparing the smartest person to the less smart person. so anyway, so you're just comparing smart to smart, and then, and so forth, all the way down the list. So that's what matched pairs is. And so what that does is it gets rid of that wall between the two samples, and it creates a connection between the two samples like that. And so examples of this would be if you were to match up students by their IQ score or ACT score. You could have dieters matched by initial weight. This is a great example because if you have dieters or people who are trying to lose weight, you take 2 500-pound people and you compare them, and then 2 100-pound people and compare them, because the amount of weight that a 500-pound person can lose is much greater than a 100-pound person. And so the variability within the sample would be huge if you were just comparing the 500-pound to the 100-pound person in the amount of weight that they lost. But by pairing them up, you're gonna just say, okay, these two are similar, these two, and so on. And then you reduce the variability within the sample. So here's some examples. Oh, wait, is this one? I just have to keep track. Yes, here we go. I didn't want you to have to write this stuff down, so I have paper here that I printed. And I know that some of you are just trying to memorize everything that I say, or you can rely on the video. Is it even recording? Yeah, it looks like it's recording. So I have this piece of paper that I thought would be helpful so that you wouldn't have to copy down all of these sentences. And these are going to be some examples. Some of these are dependent sampling, and some of them are not dependent. So here's some for you. I don't know, there's probably too many, but I don't care. There's a couple. There's a couple. You're meditating over here. You can meditate on that. Yeah, if you have extras, don't worry, I'll come get them in a bit. There are a lot of absent people for whatever reason. So, first example, and then after we do a couple of these together, then you're going to work as groups to figure out the rest of them. So, here's the idea, is we're looking at this and we're looking to see, are there two samples and is there a connection between the two samples? So let's read this one over together. We have researchers looking to determine how many, whether, yeah, make sure I got the same one. Yeah, I guess the wording is slightly different, but it's the same thing. Whether students throughout the state prefer to bring lunch to school as opposed to purchasing it. So one random sample is taken from students in a certain school system where the students are asked whether they prefer to bring lunch from home or buy lunch at school. A second random sample of students is from a school system in a different part of the state, and they're asked the same question. So here's the situation. We've got a big long space here, so I'm going to draw a long skinny state like North Carolina. Here we go. Okay, that's a terrible rendition of North Carolina. But you have, here is A over here, and here is B. So A is over in Asheville, B is over in, say, Raleigh. The schools. And there is nothing that is connecting these two samples. You have different sample sizes, possibly. You know, if we go and ask every student in school A and then every student in school B, it's likely that there are different numbers. So, but we could still talk about this in terms of independent sampling. So this one is independent. I should have put a space there for this. Independent. And the reason is that there is no connection between the two samples. You don't even know if they're the same number of students. And so the hypotheses will be this, that mu sub A is equal to mu sub B. I think that is there a difference, right? Yeah, I think is there a difference? We'll just go with this. And then the alternative is mu sub A is not equal to mu sub B. So if you're trying to figure out what to do with my little piece of paper, I have space above the hypotheses where you can write independent or dependent. So that's what goes first. And then underneath, you're going to put the hypotheses, null and alternative hypotheses. Okay, just a minute. I'm going to get on the right track here. Let's see. Is the next one baseball? Baseball. I don't like baseball. Oh, no. I don't like the problem. Okay. Just a minute. Caretaker. Okay, I like this one. We're gonna skip the baseball. You can go back to it in a minute. I just want to have an example where it's a little bit more obvious than the baseball one. So with this one, this is the third one, I believe. The research project is constructed to see whether a caretaker's love of cooking has any impact on a student's desire to cook their own meals. And so to determine this, researchers choose adults who proclaim a love of cooking, sample 1, and then ask students in their household, let's see, whether they could see themselves cooking meals for their families someday, sample 2. So, well, anyway, yeah, this isn't a great example as it turns out. But here's the deal, is that this one is dependent. Here, let me just show you what I mean by this, is that you have two groups. So here I will put the group, this one here is the group of caretakers. Here we go. So if you want to think of the samples like this, you've got a bunch of people, and these are the caretakers. Who are the caretakers? I don't know. Could be mom, could be dad, could be grandma, could be the nanny. I don't know. Whoever it is, the caretakers. So that's what those are. They're in one sample. And then you have the kids. So kids are over here, and they're here. There's one of them. Here's another, and here's another. So technically, when we can collect the data, we're thinking about these groups like this. You have two separate groups. However, because the caretakers are connected to the kids, specifically, this caretaker happens to be the mother of this child, they're linked. This caretaker happens to be the father of this kid, they're linked. This is the nanny of this kid, and so on. Each of the caretakers has a child that they're connected to. Because of that, these are dependent. There is a connection between the two samples. Dependent samples. And I do not see, I guess I didn't read through all of my examples. I don't see an obvious claim here, so we're just going to ignore the null and alternative hypotheses. The main reason I wanted to do this exercise was to sort out when do you have dependent samples and when do you have independent samples. So that's what you're going to do for each one of these is you're going to write down over in the right side. So this is the third one down up here. You're going to write down dependent or independent. And then if there's an obvious null and alternative hypothesis, we will deal with that. But there isn't in this case. So, yeah. Anyway, so go to it and see if you can identify the rest of these, dependent or independent. You can work with a friend. In fact, I encourage you. I almost should insist that you work with someone, but I won't go that far. But take a few minutes while I get myself squared away up here and try to get this up on the screen. Where's my paired handout? Okay. There we go. Let me interrupt you for just a second. Now that I've thought about it, don't fill in the null and alternative hypotheses because there are a few of these that I want to make sure we do together. And doing a dependent sample hypothesis is going to be a little bit weird. So leave those blank for now. So. It looks like some of you are, maybe you're just asleep. Is he okay? Okay, sorry. That's the way I feel sometimes as well. Don't worry. I sympathize. Yeah, so let's go ahead. We'll work on it together because some of you are like, I'm not going to talk to anyone. I refuse. Okay, well, let's talk now because if I call on you, you get to talk. Amy gets to talk first. What do you think about the soccer games or soccer and baseball? So it's independent. Why is it independent? Yeah, so independent. There's no connection between the schools. So very good. Independent samples. Very nice. So you have these two. I don't know what the hypothesis should be. That's really not the purpose of this. I guess for some reason when I put this together yesterday, I thought, I don't know what I was thinking. Let's move on. Pharmaceutical company. We got this. Kirsten knows what this is, don't you? What's the, is this independent or dependent? Dependent. So if it's dependent, that means that there must be a connection. Dependent. Sorry, I can't spell today. So there's a connection between the two samples. So let's find out what is that connection. Briar, you thought it was dependent as well, didn't you? Excellent. What is the connection between the two samples? I've got before and after. What was it? Wait, AJ, what did you say? It's the same people. Yeah, so it's the same people. You have person. So if you think of these two samples as being before and after, so you have before and you have after. The before is before medication, and then after is after they've taken the medication for 60 days. You have the same people. So this same person, so the same sample. So it's actually the exact same people giving the same stuff. Now, when we do our before and after, when we test you guys, of course, there's going to be some befores that don't stick around, and we don't get the after score. We just get rid of those people from our samples, so we don't worry about them. Not that they don't matter, but they don't get to be in our sample. So the same thing here. If someone decides to quit the study, I guess they would just disappear. So yeah, it's definitely dependent. Very good. All right, Caden, what do you think about this next one? The teacher claiming students in his math classes prefer math to English. Independent. So if it's independent, it means that you have two samples that have nothing to do with one another. What are the two samples? So it's math to, but that's what they prefer. Who's being asked this? Oh, so it's these people. This is sort of similar to the previous one. So shouldn't this be dependent? I think it should. So let's get rid of in and just make it dependent because you have the students and they're asked, how do you feel about math? Rate it from 1 to 10 maybe. Math. And then they ask the question about English. So it'd be like, so it's kind of hard because there's like a single sentence. It's a short sentence, doesn't say much. But to envision how I would do this, I would ask my classes, I would ask each of you, maybe in a survey, rate your love of math between 1 and 10. And I know all of you would be like 9s and 8s and 10s. And then rate your love of English on a scale of 1 to 10, and you'd be like a 5 or 2 or 7. And so then I would compare each student, and I'd say, okay, what does Noah think about math compared with what Noah thinks about English? And then I'd ask about Bailey and Aubrey and so on. So each individual has 2 scores that they've provided to me. So same sample, this one is dependent. Okay, next one. So that might give you a hint as to what the next one is. Bailey, what do you think about this next one? Is that dependent or independent? It is dependent, very good. Because it's almost exactly the same question. You've just changed who you're asking and you're changing the question. But it is, you've got these people, Washingtonians, and they're going to be asked, how do you feel about Spokane? How do you feel about Seattle? That sort of thing. Oh no, I guess it's Spokane people. People living in Spokane, they think, yeah, so whatever it is, they ask. Anyway, let's move on. Okay, we will get to the hypotheses in just a minute, don't worry. Yeah, I don't know what happened to my stuff here. Let's do the fast food organization. Next volunteer, Haley. What about this fast food organization? Are these dependent or independent samples? Oh, what's connecting the two samples? Dependent. So there must be something that connects. So what are we doing? We're asking how much soda is dispensed before and how much soda is dispensed after you change the equipment, right? So what's up with, what are the two samples? Those are that's the question we're going to ask. Who are we asking that question to? Franchises. So the franchises are the same. It's the same franchises. We're asking the same question, the questions to the same friend. So you don't have two samples. It's a single sample. So it's dependent. So this is kind of like with the number 4 and number 5, number 7, oh, and 6. Sorry, yeah, all four of those are dependent for the same reason, and that is you have a single sample. You're asking two questions of that single sample. So how did things go before? How did things go after? That's the sort of thing. So let's talk about hypotheses. Let's see, do I have my hypotheses on PowerPoint? Yes. Let's talk about hypotheses. So to understand the hypotheses, I need to introduce some notation. And so here's the notation. I call these are parameters because they're, oh, here, I guess I need to tell you what I'm talking about here. So this is the weight loss situation. We have the weight loss. So this isn't on your page. I should have put it there. But let's say that we are matched by initial weight. So I've got a bunch of students, and I have 2 students who are 250 pounds at the beginning of the semester. I have 2 students who are 175 pounds. I have 2 students 200 pounds, and 2 students who weigh 160 pounds. So maybe they're all guys, probably to keep things, less variability. But so you have these students, and I'm going to separate them randomly, and I will say, okay, of you two, one of you is going to be just use diet, no exercise. One of you will exercise, no diet. And we will collect the amount of weight you lose during the semester. So that's what I have here. So this is a matched pairs situation. So these are dependent samples because I have paired the students up. And there's an obvious pairing, but here's how we are going to do the hypotheses. And we'll go back and do them on the page in just a minute. So the parameters, first of all, mu sub 1 is the average weight loss for dieters. So if you take all the dieters and find the average, and then you can take all the exercisers and do the average. If these were independent samples, we would say that my hypothesis is that the exercise weight loss is greater than the dieter weight loss. Is that what it was saying here? It doesn't say, but that's going to be my claim, okay? My claim is that exercise is more effective than dieting. And so, so my hypotheses, if this was independent, the hypotheses would look like this. You have mu sub 1 is less than mu sub 2. Sorry, that's the alternative. The null hypothesis is mu sub 1 is greater than or equal to mu sub 2. So that's independent. If we have dependent samples, what happens is you introduce a new parameter, and that's this one. It's the average difference in weight loss for exercisers and weight loss for dieters. And now my alternative hypothesis is that this average difference is, let's see, exercisers minus dieters will be bigger than 0, and the null hypothesis is that the average difference is less than or equal to 0. Now here's something super important mathematically about this situation, and that is that the difference, the average difference, is not just the difference in the averages. If I take the average difference, that is compute differences, average those numbers together, I get something different than if I do the average of the exercisers and subtract off the average of the dieters. So anyway, this is what our hypotheses will look like. So let's go ahead and do this for some of the ones on this, just to show you how this works. I've made a mess of this. Just a minute. Let's do the medication, number 4. So let me work on number 4 with you. So let me move this out of the way. Whatever. Okay, good enough. We'll just push it over there. Okay, I don't know what happened. Mine is not lined up well. So I'll just make a new null hypothesis. So first off, I have to say this. Mu sub d is, let's see, should we do average? What are we doing here? Cholesterol. And we want to know whether the cholesterol medication will decrease the cholesterol level. So let's do before minus after. Now that equation is not really technically correct. I'm just writing it there to clue me in as to how I'm thinking about this. So the difference that I'm interested in is the before minus the after difference. So then if the cholesterol did decrease, then the claim would be that this difference is going to be bigger than 0. So notice that the before minus after, if we actually reduce the amount of cholesterol in these people, then before minus after will be greater than 0, so you would have decreased. So that's why it's really important to write down exactly what you mean by everything. Because if I had done after minus before, then this would go the other direction, wouldn't it? Because my after is less than before, so if I do after minus before, my difference would be less than 0 if my claim is correct. So now that I have that, I can write down the null and alternative hypotheses. The null hypothesis, of course, is mu sub d is less than or equal to 0, alternative greater than 0. So yeah, I guess opposite, we could do opposite, less than or equal to, sorry. Okay, so let's see, yeah, let's see if we can let's do 6 and 7. Let's see, yeah, 6 and 7. 6 and 7, just to make sure that you know how to do this. So here are your jobs. With each of them for 6 and 7, let's not do 5. For 6 and 7, you're going to write down what does mu sub d represent. Like up here, it was before minus after. So what does it represent in terms of in the context of the problem? And then after you do that, you're going to say, what is the claim? What's the claim? And then you'll fill in the hypotheses for each one of these. So 6 and 7, take a minute, work with your friend if you need to. All right, well, we do need to move on. So I need to, let's see how we're doing with this. So this is the crucial question. This next question is, how do we write the difference? So what difference are we interested in? Like, is it before minus after or after minus before? So there's no wrong answer, by the way. Well, almost no wrong answer. So, but it will affect the claim and it will affect the hypotheses. Okay, so Lily, what do you want to use for number 6 for the difference? What difference? Okay, I like your Seattle minus Spokane, but I'm going to do it this way. Just a minor difference, just to clarify. Seattle minus Spokane. And this is actually not going to be the number of people that prefer. It's rather going to be the score, if you will. Like, so I guess I'm envisioning these Washingtonians, give them a survey. I say, rate the city of Spokane on a scale of 1 to 10. And then you have another one, rate the scale of Seattle from 1 to 10. So basically you're rating them. And so it's the average rating for Seattle versus the average rating for Spokane. And the reason why this is going to reduce the variability is because you might have someone who thinks the entire state of Washington is terrible, kind of like what you guys think about the state of Michigan. And so what they'll do is they'll say, oh, I hate both of those cities, but they might prefer Seattle to Spokane, even though they say Seattle's a 2 and Spokane is a 1. And then you have people that feel great about the state of Washington, and they're like, oh, Seattle is a 10, Spokane is great, but not as great, it's a 9. And so this reduces that when we look at the differences, we're only interested in how did each people compare. So I might have, this is not super clear, so but that's the way we're going to do it, is we're going to take the average Seattle and the average Spokane. We're going to compare those. So what is the claim about mu sub d? That's what we want to know. And so this claim, it's going to look something like this, mu sub d. And how does it compare with 0? That's what I want to know. So Alex, what do you think? Do we think that mu sub d, when we get done with these differences, are they going to be bigger than 0 or less than 0? Very good, bigger than 0. And so Alex correctly noticed that when we think that someone prefers Seattle to Spokane, we would think that their Seattle score is bigger than their Spokane score, which means that they would have a difference that's bigger than 0. If we thought the opposite, then we would say less. Like if we think Spokane is more popular than Seattle, we would go the other way. Okay, very nice. So now we can figure out the null and alternative hypotheses. That's easy enough. I'll just do it because you know how to do this. You've done a great job with that in the past. Well, most of you. Okay, let's get on to this because we still have to show you how to finish all these because I know we're just setting things up. We're almost there though. Okay, so I need to know what is the difference that we're interested in here? So Abby, what do you think? How do you want to set up this difference for the fast food?
The amount of liquid before and minus after.
Okay, so it's before minus after. Before minus after. So we have the average before and the average after, and then this is the average difference. So we're taking each store and we're saying, okay, what's your before and your after? We'll subtract, and then we'll go to this store, before, after, subtract, and then we'll go over here, before, after, subtract. Very good. So we've got that sorted out. If we did after minus before, it would be different. Well, the next step would. Okay, Carter, what is the claim that we're making? So that was, oh, wait. Let's see. Yeah, this one's confusing. Do not underfill. So if we're talking about underfilling, then we're expecting before to actually be less than after, right? Okay, so before, so yeah, that got me as well. So I think we want to do the opposite. We want to say that it's less than 0, which would mean that before, yeah, it's hard to imagine. So before we're underfilling the cup, so they're putting it to the machine. It's supposed to be a large, but you end up with this much, whatever it is, cheer wine, whatever it is that they're putting in there. It's only about a medium amount instead of a large amount, and that makes customers angry. So we want to make sure that we aren't underfilling. So before, we're presumably underfilling now. We're hoping that we don't now. So or in the future. So before minus after, I think that we would get less than 0 there. Okay, but then once you have that, the null and alternative hypotheses are easy enough. Mu sub d and mu sub d is less than 0. Okay, so we still need to see how we're going to solve these. So let's go to the solving. So since we're interested in the differences, this particular situation, let's compute the differences. So what you're going to do, difference, and you would do this probably in Excel. I can't remember, to be honest, how Newton has this set up, but if they have 2 columns like this, then you're going to have to compute the differences yourselves. If they've already got the differences, then you would just use the differences. So wait, here it is. We are interested in the difference being greater than 0. I just got to remind myself, dieters and exercisers. So this is exercise. I better write this down. Mu sub d is exercise minus diet. How about that? Okay, so we need the differences now. Difference is exercise minus diet. There is a 10-pound difference with that couple. There is a 10-pound difference there. There is a 10-pound difference there, and a 20-pound difference there. Okay, now at this point, what we're going to do, and I don't even have, do I have it set up? I do. I've got it here. What you're going to do is, I don't have it set up. Let me pull up my hypothesis test gold. I know you're dreading this because you're probably sick of this. Okay, so I'll pull this over. So, that's not right. What am I doing? Just a sec. Let's do this. Hold on. Pull this over. And I want this to be on that side. There we go. Let me get rid of this. Okay, so there are my differences. We're going to go to hypothesis test gold. And I don't care now. Once I've computed the differences, I don't care about the individuals. I just care about the differences. It's as if I have a single sample of these numbers. 4 numbers, it's a sample, single sample, and I'm going to compute the mean. And so because of that, when you do this on Excel, you just basically revert to doing a single sample. Let's see, can I do this? So we're going to go down here and try to find, there it is. It's one of the first ones we did, the one mean. Oh, what's all that? It doesn't look the same as I remember it. Yeah, it's the same though. So we're going to have to compute the mean. I suppose that since I have the data and it's a short data set, I can just type it in. So we have 10, 10, 10, 20. Let's do this. Equals the average of these numbers, and then equals the standard deviation of these numbers. I think I can count them in my head. I don't need to use Excel. So this is 12.5 for the average. Standard deviation is 5 apparently. There are 4 numbers. And the null hypothesis. Null hypothesis is back here, right there. Mu sub d is less than or equal to 0. So that's what you're going to use for the null hypothesis, 0. Now that we've got that, notice that this is pretty simple. If you have this stuff working, ignore this stuff down here. I don't know what that is. But if you've got your hypothesis test gold spreadsheet working for one mean, you can just take that and pick the correct one. It's right-tailed. Test statistic is 5. Right-tailed test p-value is 0.007. This, we're going to definitely reject the null hypothesis, and there is evidence to suggest that dieters are not as good as exercisers, or that the average difference is greater than 0. By the way, just one quick note about this is that this study about dieting and exercise has been done in real life, and it turns out that it is true, that exercise is better than dieting. If you do no dieting, you just exercise, you lose more weight than if you just diet, don't exercise. So just for future reference, statistics you can use. All right, that should be it, I guess. We didn't do any other examples, but if you do have trouble, do email me and I'll make a video. Stopping the stream.